And this would be in a system of equations, system of inequalities. So in a system of equations, which is what we just did, and we just had our quest on, there's an equal sign. You'll either have an ordered pair solution, a no solution, or an infinite solution. Well, today we're going to talk about a system of inequalities. Well, an inequality does not have an equal sign. It has a greater than, less than, greater than equal, or less than equal to sign. And this time you're not going to be able to say that there's going to be an ordered pair or no solution or infinite solution. When you solve a system of inequalities, it will take shading. So this time, solving it by substitution or elimination will be an opportunity to get the point of intersection, but that's all it's going to give you. Then you're going to have to pick a point, and you're going to have to shade to the left or to the right of the boundary. So let's go ahead and put an example up here and let's walk through it. Up here on the board there is a system of inequalities. It's a system because there are at least two equations with at least two unknowns, and there's more than one of them. So step one is I am going to have to graph each boundary. Well, every time I graph a boundary, then I'm going to shade. So let's take the first inequality, and it was y is less than 6. What type of line is y is less than 6? Well, that would be a horizontal line. That would be my boundary. So 1, 2, 3, 4, 5, 6. And that line would be a dotted line up at y is equal to 6. Now that's my boundary. Well, then the second part is I got to shade. Well, how do I shade? Well, remember, you pick a point. So we're going to pick a point that is not part of the boundary. Well, the easiest point to pick is 0, 0 if it's available. So then you're going to put that into that inequality, and let's test it. 0 is less than 6. Is that true or false? Well, it's true. So I'm going to take my other color and I'm going to shade where that point is. So anything below that line will make it true. Well, I have two inequalities, so now I have to do the second one. So let's go ahead, and that is y is greater than x plus 3. Well, what form did they give it to me in? They gave it to me in slope-intercept form. That is pretty nice. So I'm going to graph my y-intercept, which is 3. 1, 2, 3. I put my dot. And then I move my slope. And my slope is 1, so I'll go up 1 over 1. Or I can go down 1 over 1, either way. This boundary is also dotted because it doesn't have the equal sign. So I'm going to go ahead and I'm going to connect my dots. So I've graphed that boundary. And now I have to shade. How do I shade? I pick a point that's not on the boundary. Oh, guess what? 0, 0 is again available. And so I'm going to put that in up here. And that would be 0 is greater than 0 plus 3. So 0 is greater than 3. Is that a true statement? Well, no, that isn't a true statement. So I cannot color that point. But I can, however, color on the other side of the boundary, and that gives me this. So Step 1 is graph each boundary and shade. That's what I've done. Well, step 2 is where do the shading overlap? Well, where the shading overlaps is in between this line and that line because I have orange and green going together. So that right there is I might darken that shading in that area because, watch this, if I go in here and I do this, because that's where they overlap the shading, that is my solution. So any point that I chose in this darkened area will satisfy both of those inequalities. Well, we've already graphed inequalities. That's nothing new. The only difference is we're going to graph two of them, and we're going to see where they overlap. So let's do one more. Okay. Here's another system of inequalities. So let's look at them. And I have 3x minus y is greater than or equal to negative 2. And I have y is less than 3x plus 4. Well, this guy right here, there has to be something that's done to it. So what do I have to do to this one before I can do my step 1, which is graph the boundary? Well, I have to put it in slope-intercept form. So step 1 on this guy right here is I'm going to bring him down here, and that gives me 3x minus y is greater than or equal to negative 2. To get it into slope-intercept form, I need my y to be alone. So that means this guy right here has to be by itself. So I'm going to subtract 3x from both sides. That gives me bye-bye, baby, bye-bye. Negative y greater than or equal to negative 3x minus 2. What I'm going to do here is, I don't have y by itself. I'm going to divide everything by negative 1. And then my little sirens go off and they go whoop, 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 whoop. Why do they go off? They go off because I'm dividing by negative 1. So what does that mean I have to do to my inequality? Flip it. So now this problem becomes y is less than or equal to, because I flipped the inequality because I'm dividing by negative 1, that gives me 3x, and that gives me positive 2. So now I have this one in slope-intercept, and I have the second one in slope-intercept. Because I added a negative in that second one, so make sure you go look and see if you have it copied correctly. All right, so now that was like preliminary. Here we go. Step 1 says graph the boundary. So let's go graph my boundary. And since this one's here, let's do this one first. So I'm going to graph my 2 on the y-axis, and then I'm going to move my slope, which in this case is, it's a whole number, so it's going to be 3 over 1. So I'm going to go up 3, 1, 2, 3 over 1. I'm going to put a dot. Or I could have gone down 3, 1, 2, 3, and over the other way 1. And I know that since the slope is positive, it's rising into quadrant 1. I look at my inequality, it has an equal sign, so it's going to be a solid boundary. Oh, I love those. So my boundary looks like this. Now, that's the first half of number 1. And the second half is I have to shade. So I have to pick a point. Well, what point am I going to choose? I'm going to choose 0, 0. And I plug that in, and just in case I made an error, I'm going to go back up to the original. And I plug in 0, 0. So that gives me 0 minus 0. And the question is 0 greater than or equal to negative 2? And in this case, it is true. So I get to color my point. So I'm going to go get my color, and I'm going to color where 0, 0 is, and that looks like this. I did that for one equation, and now I have to do it for the other inequality. So to graph this one, it's already in slope-intercept form, and so I breathe a sigh of relief. And I go graph my y-intercept 4 on the y-axis. 1, 2, 3, 4. I am now going to move my slope, which is negative 3 over 1. So I'm going to go down 3, 1, 2, 3, right 1. Or I could have gone up 3, 1, 2, 3, and over 1. Remember, a negative slope rises into quadrant 2. This time my boundary is dotted, so I'm going to dot that boundary. Okay. So I've graphed the boundary, and the second part is shading. So I have to pick a point. Oh, good. This point works again, so let's do 0, 0. 0 is less than, oh, that's negative 3 times 0 is 0. I almost made a mistake. Plus 4. So is 0 greater than, let's try that again. 0 less than 4? Is 0 less than 4? Oh, it is true. So I get to color that point and that side. So now I have this guy right here. Oh, and he goes, oh, here he is. So step 1 is complete. And then step 2 is darken the overlap. And that would be in between these two lines. Let's see. Oh, here it is. And that is my solution. I'm going to draw a picture based on that picture right here. Okay, up here on the board, I've drawn another graph of the system of inequalities. And you'll notice my green and my orange share nothing. So what do I have to darken? I don't have anything to darken. So what would be my solution in this case? There would be no solution. None. Now another possibility you'll notice that my black and my orange overlap, and they overlap on that whole side of that other one. So all I would have to do in this case is darken everything over here that's on the left side of that line, which is the boundary, and I would be fine to go. Lines do not have to intersect like my two examples did. They could be parallel, okay? And the solutions could be on the outside, which means there's no solution. They could be all of the one and not that part that's different. That's another one. Can anybody think of another type of solution? About the river running between the two parallel lines. What if the top one went this way and the bottom one went this way? And when I looked what I have to overlap and darken, it would be the stuff in between them. Well, the best part is when they give me the system of inequalities and all I have to do is graph them and find the solution. But everyday life is an algebra problem. We don't think of it that way, but it is. So therefore, there might be times that you have to write your own system of inequalities. And that we'll talk about when you come to class. What I would like you to do for tonight, check your understanding problems 1 through 9 odd. So I want you to do the check your understanding 13579.